In this video, we're going to dive in and learn about the recently added if functionality inside of Fusion 360 parameters, so stay tuned. Hey everyone, this is Matt with Learn Everything About Design, and in this video we're going to take a look at the finally added if statement into the Fusion 360 parameters. Now, this is something that should have been there for a long time, and I really don't know why it wasn't, because if statements were available in Fusion in CAM expressions in the manufacturer workspace, but they just were not in our logic. And we've done previous videos on this where we looked at using things like floor and ceiling and various different logic operators that we had available. But now we've got the if statement, and I want to take a second to talk about it in its own video. So if you want to follow along, you can go to the description of the video and you can download the dataset you see on the screen here. And I also have a link to the help file for Fusion 360 that gives you more information on the logic function. Now, what I found in playing around with this is that it's a little tricky to get right, and we need to take a little bit of time to understand how the logic works. If you've never used an if statement before, then this is going to be probably a little bit of a stretch. If you've used it before in coding, whether it's Arduino or Python or C or whatever, then at least you have some experience with what the if statement does. So let's take a look by going into Modify, Change Parameters, and let's just take a look at the parameters that we have in this design. We've got a flange OD, which increases or decreases the outside diameter. We've got a flange ID, which is going to increase or decrease the inside diameter. We're not going to be messing with that for this video. We have a hole instance, which will increase or decrease the number of holes in the pattern. We've got flange width, again, not going to mess with. And then we've got this pattern rad, which is radius. And essentially it's taking the outside diameter minus the inside diameter minus ½ inch, which is the hole diameter we're using, and it's dividing it by 2 to give us the radius of where to put that in the middle of the flange. Now there is a limit to this design. I didn't spend a ton of time setting it up. Things like if you go below or if you go down to 4 inches, things are going to fail because the hole is exactly touching the corner and then the chamfers start to fail. So again, not a fully robust model, but it's going to suit our needs fine to figure out how to use if. So when we get started creating an if statement, there are a couple of things that we need to be aware of. We're going to be modifying the whole instance parameter, which is unitless, and this is perfectly fine. But with all of the Fusion 360 parameters and also other CAD programs as well, you need to be aware of the units that you're driving. You want the end result to be, in this case, unitless. If we had to have a unit, we would probably have to multiply by 1 inch or whatever the units are. So we're starting off with just a unitless parameter expression, which is 6. And we're going to change this to an if statement. We want to configure this model so that if the outside diameter changes to a certain amount or above a certain amount, we want to increase the number of holes that we have. So we can start this by starting a bracket, or we can just start typing if. You see that the if function shows up. We've already have it typed, so we don't need to click on it, but you can, or you can hit enter, and then it'll automatically create some brackets for us. Now, the way that an if statement works is it's conditional logic. It's checking the first statement, and if that's true, then it knows what the answer is, and if it's false, then it has an alternative answer. So in our case, we're going to say if flange OD is greater than or equal to 6in, we need to put the inches in there, and then we're going to use the semicolon to separate this if statement from the what happens if it's true. So if this is true, we want the number of instances to be 8. We use semicolon again. If it's false, we want the number of instances to be 6. And you can see that the parameter is no longer red because it has all the conditions it's looking for. We hit enter, and we can now test this out. So greater than or equal to 6 inches means that if we take this up to 6 inches, the number of holes should change to 8. If it's below 6 inches, like 5.75, it should go back down to 6. And this is completely true all the way down to as small as we can go. Let's say 4.25. It's going to still have 6 instances. But the if statement with just a single logic or single condition oftentimes isn't enough, and we need to get into what's called a nested if statement. And this is where the logic and the structure of this if statement in Fusion becomes a little tricky. We need to be very careful, and we need to notice a couple things. First, our entire if statement is inside of a bracket. And each element of the if statement is separated by semicolons. So if we want to dive into a nested if statement, we need to add a couple of additional brackets, and we need to be very careful where each piece of that puzzle is. So in our statement, if the flange OD is greater than or equal to 6 inches, we have 8 instances, or else it's going to be 6. But what about a condition that is lower than 5? Let's say that we wanted to add another if statement here. So after we get past our true condition, 8, we want to replace our false condition with another if statement. So I'm going to start it with a bracket. I'm going to type in if, and we have to remember here that our if statement needs to be in its own bracket. So now we're going to say if flange OD is going to be less than or equal to 5 inches, and again, we have to separate this with a semicolon. If it's less than or equal to 5 inches, then we want the number of instances to be 6. And here is where it's going to get a little bit tricky, because now this if statement is inside of brackets, inside of brackets, inside of brackets. And it gets really complicated to figure out where things need to be. So what we want to do is we want to just make sure that we understand what this logic is doing. So at this point, I'm going to put in semicolon, and I'm going to just say for the other instance, and I'm going to try to close off all these brackets. So now what's happening is, if we take a look at this, if our flange OD is greater than or equal to 6 inches, we're going to have 8 numbers or 8 instances of the whole. Conversely, if that's equal to or less than or equal to 5 inches, we're going to have 6, and then the false case of that is going to be 4. So right now, the way the logic is built, there's really it's this kind of weird in-between value. So the weird in-between value is right now greater than or equal to 6, less than or equal to 5. So what happens if it's in between 5 and 6? And that's where that 4 value comes in. So this is where we need to really think about the logic. These two should be switched. We'll make this 6, and if it's smaller than that, we'll make this 4, and then we'll hit enter. So now, if we are looking at this, if we say 5 inches, 5 inches less than or equal to 5 inches, we've got 4. If we go above 5 inches, 5.25, we should now get 6 holes. If we go to 6 inches or above, we should get 8 holes. And this is why I say the initial logic of the if statement is not too bad, but once you start getting into these nested statements, it can get really out of control really quick. What I like to do is I like to just do this in a separate document, whether it's in Excel or just a Word document or whatever, and really look at the logic that I want, because if you just try to figure it out and type it into the Fusion parameters dialog, it can be pretty complicated, and it could be easy to just throw your hands and give up. The last thing that I want to take a look at is one more case that I think recently came up in the What's New video in Fusion. And what happened is they were doing an if statement, but they were using a sort of a logic operator, a 0 or a 1. And I just want to mention that here so we understand how to do it. So I'm going to create a new parameter. This is going to be unitless, and I'm just going to call this my logic operator. And I'm going to set this to 0, and I'm going to add a comment, 0 for no, 1 for yes. So the comment displays over here on the right-hand side, and then we're going to add a new user parameter. Now, in this case, what we want to do is we want to reference that logic operator and give it some sort of expression. So in this case, maybe we want to change the ID or the OD or some sort of parameter based on our logic operator. So what we're going to say is we're going to call this one our conditional. And this value is going to be in inches. And the expression is going to be our if-else statement. Now, this can be kind of hard in this small dialog, but you can drag it out and make it as big as you need to. And what we're going to say is we're going to say if, bracket, logic operator. And in this case, because we're dealing with either a 0 or a 1, we're going to use equal equal. And this is a little bit different because whenever we're doing logic operators, we either need to have less than or equal to, greater than or equal to, greater than, equals, or even not equals. We can do a not equals. But we're going to do, if the logic operator is equal to 0, and then we're going to say 6 in for inches, else 4.5 IN, and we're going to close the brackets. So now what we're doing is we're referencing this logic operator 0 and 1, and we're going to use it to control our flange OD. So I'm going to come up here and I'm just going to say equals conditional. And notice that we get an error here. Now it's telling us that it failed because of the parameters expression. Now, and that's because I put this equals in here and I really don't need it. So what I want to do is go back in and make sure that I get rid of that equals and just set that equal to conditional. So now if I change this to a 1, we should see the OD of the design change. If I change it back to a 0, then it changes back to the original. Now you can use this logic to create some sort of a configuration of your design using an input 0, 1, 2, 3, 4. Let's say you're configuring the number of shelves or drawers in a desk, or you're configuring the number of hole patterns on a design. You can use these values, these logic operators, in conjunction with if-else logic to drive the rest of your design. It takes a little bit of time to get this set up and to make sure that you understand how to do the if and the nested if statements, but the best way is to get in there and to start playing around with it. I suggest starting here with a logic operator, something like a 0 and a 1, and then generating an if statement that can help control a parameter in your design. Once you get comfortable with that, move on to doing nested if statements and see how you can control that. And once again, make sure that you do go to the help file and check the logic operators and the functions and everything that you can use in Fusion, because you can get as complicated as you want with this. At this point, if you have any questions, please let me know. As always, thanks for watching, and we'll see you in the next one.